Mr. Ryan, how are you today?
Good.
Good. It's Friday, okay? Okay, let's do it. So, today we're going to count the numbers with unique digits. So, what are the numbers with unique digits? Like 1, 2, 3, this is unique digit. But 1, 2, 2, this is not unique digit because 2 appears twice.
How about appear 3 times?
It's if it appears more than 1 time, it's not unique digit. Okay, so given a number n, we want to count how many numbers with unique digit between the range. Okay, suppose this is x. Between the range bigger than 0, smaller than 10 to the power n. Okay, 10 to the power n. 10 to the power of 0 equals what?
10 to the power
Any-
0.
No, 1.
One.
1.
Okay.
10 to the power 1.
10.
Okay, 10 to the power 2. 100, yeah?
Yeah.
Got it. 2 to the power of 0.
1.
Yes, so any number except 0 to the power of 0.
Or 0 to the power 0.
Good question. Ideally it's 1, but maybe mathematically it's not defined. So any number except the 0 to the power of 0 is 1, okay?
Yeah.
Okay, so do you still remember the binary? Yeah, binary. Why is that? Look, so binary 1 0 1 0. Okay, so this means 1, right? Yeah, yeah. It's 2 to the power of 0. Like 123.
1, 2, 3.
This is 1, right? Ones. We call it ones. Yeah. This is tens, right? This is 100. All right? Yes. Right? So that's 100 plus 20 plus 3. Got it? So that's why 10 to the power of 0 is 1. 10 to the power of 0. Yeah? Got it?
Mm-hmm.
So look, so we're given this n, and we want to count how many numbers are unique with unique digit. It doesn't have any duplicate digit between this range. For example, when n is 0, how many? When n is 0. So smaller than 1. So how many numbers within this range is unique? Is unique. How?
Has all different number.
Yeah, it doesn't have duplicate numbers.
Okay.
So how many numbers? How many numbers with this range? Look.
2.
Well, no, smaller than 1, bigger or equal than 0. So it must be, the only possibility is 0, right? Yeah?
Yeah.
So it's 1. The answer is 1 because there's only one number which is unique, 0. It doesn't have any duplicate numbers, right?
How about 1?
1 is less than 1. No, 1 is not less than 1, yeah? Okay, how about n is 1? So that would be what? X bigger than 0, smaller than 10. So how many numbers with this range have unique? 10, yeah?
Yeah.
It's 0 to 9, right? That's 10 numbers.
Yeah.
Okay, so you got it, yeah? And then how about 2?
2.
So we want to count bigger than 0, x smaller than 100. So any idea how we're counting this? If you're not sure, we can always...
11. 22.
No. Look, any numbers. How many numbers within this range? 0 to 99. How many numbers?
9.
0 to 99. How many numbers?
90.
0 to 99. How many numbers? Come on.
There are 100 numbers.
100 numbers. Yes, 100 numbers. But we are excluding. We need to excluding 1 1, 2 2, 3 3, 4 4. How many of that?
9.
Okay, so 100 minus 9.
91.
Yes. Okay, so if n is 2, we need to return 91. Okay? Yes?
Yeah.
So how, if there are n numbers, if n is bigger than 10, for example, what's the answer? If n is bigger than 10, so the answer will be F10, right? Because look, if it's the if you can't find any n-digit number with unique digits when n is bigger than 10, right? Why is that? Because look, if n is 11, you can't find any 11th digits with unique digits. Am I right?
Yeah.
Because you only how many digits have you got? No, how many altogether digits you have got? 0 to 9, how many? How many digits? 0 to 9. 0, 1, 2, 3, how many? 10 digits, because we are in decimal, okay?
Yeah.
So we have 10 digits. And we want to put it in the 11th box. We count, right? Do you get it? Alright?
Yeah.
Because look, if 11, we call it pigeons, yeah? Pigeonhole, yeah? We have 11, we have 10 pigeons. Pigeon, you know pigeon, the animal, yeah? We have 10 pigeon birds. And we want to put it in the 11th pigeons. Yeah?
But there's only 10.
There's only 10. So what could happen? So
0.
So at least one of the pigeonhole is empty, right? Am I right? At least one. Can we get that? Yeah. At least one of the pigeonhole is empty. Am I right? Does it make sense?
What's a pigeonhole?
The cage to put the birds in. Okay. Okay. Oh, for example, like you have 10 balls.
Balls. Yeah.
Balls, and you have 11 box. Okay.
Yeah.
And you want to put the 10 balls into the 11 box, and we can get at least okay, we're talking about at least one box is empty. Can I get that? Yeah?
Yeah.
Yeah? That's obvious, yeah, because you only have 10 balls, and how can you put it in the 11
Timetables.
11 boxes, right?
Yeah.
You can put all of them into one, but or you can the best you can do is put 10 balls in 10 boxes, and then now you have one box which is empty. Am I right? Am I right?
Yeah.
So coming back to this question, if you have 10 digits and you want to put it in the 11 digits, you can't find this without duplicate, right? Am I right?
Yeah.
If you have 11 digits, it must be non-unique. Am I right? Am I right?
Yeah.
Does it make sense? Yes? Okay. Okay, so now coming back to this question, okay? Look, if there are 3 digits, okay, let's define, look, Eric, if there are 3 digits, how many possibility I can put for the first digit? If there are 3 digits, 3-digit number, okay? 3-digit number. How many possibility I can put for the first digit?
3. 9.
9. Why is 9?
0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
That's 10.
10! No, wait. Not 0.
Not 0, so 9, yeah?
Yeah.
Good question. Because the first digit can't have 0. You can only put 1 to 9, right?
Yeah.
The second number, how many possibilities?
1 to 9.
1 to 9, 9.
Yeah. Yeah. No, 10.
One more guess?
4,000.
One more guess?
I guess.
Is it 10 or 9? That's for the second digit. Because we have already used 1 digit here for the first case. But we have one more.
No, 9. Yeah, 9.
Why is 9? Can you tell me?
Because you actually can do 10, but you already used 1 for the first one, so you subtract 1, so that's 9.
Yes. Because for the second number, I can use 0, right?
Yeah.
I can use 0. And then I use 1 at the beginning. And I plus 0, so that's 0. That's 9. That's 9 possibility, including 0. Okay, so for the third one, how many possibilities?
8.
Yes, because we used 2, and now we have 8, yeah? 8. So how many possibilities if I add one more 0 here?
7.
We're done. Okay. So you get it. If we have a function fn, fk, meaning k-digit number with unique digits, yes? Then we can calculate this way, right?
Yeah.
Okay, so let's do it. let's do it. Define count. Okay, count n. Remember, count n. What's missing here?
Column.
If n equals 0, return what?
Tuning.
Return how many? Remember, this is a special
Zero.
case.
None. None. None.
1. It return 1. Remember. Okay, so now we define f. F, remember, is the n size. Fk. We can define another function here. What's missing here?
Column.
K is the
Always.
k digit.
That's
K
not
digit.
column, that's an equals.
K digit number which is unique, which only has unique digits, right?
It's not a column.
Okay, now look.
It's an equals.
If k equals 1, return what?
K equals 1. 1. No, 2.
K only one digit. How many can we get? How many digits for the 1? One digit. I mean 1 digit. How many 1 digit?
1.
Should we return 10 instead? 0 to 9, right?
Yeah.
10. Okay. Then we can do this answer equals 1, right? Then for I in range what? K
Something.
K look at is what? 9 times 9. We want to calculate this. 9 times 9 times 8 times 7, right? And times here.
648. No.
No, look at K, maybe K plus 1. I'll come back to that. Okay, so answer equals answer times. Look at the 10. The should be 10 minus I, right? Let's do. It should be 1K. When I is 1, then you times 9. When I is 2, actually, let's put it 9 here. So because the first number we want to times is 9, and then when k is 2, we want to times I, right? And then return answer. Okay, does it make sense? Does it make sense? Can you get it? Because we want to calculate. We want to calculate the f is the number of digits. Fk is the number of k digit numbers with unique digits. Okay, with unique digits. So this function will return the number of numbers with unique digits for k digit numbers. Okay, it's a bit tricky. Yeah.
Really?
Yes, I think that I think we probably don't need this because k equals 1. K equals 1, it should return 9 because only this may not work, so we don't do this. Okay, and now we need to sum this up. Look, sum return sum f k for k in range n plus 1, right? Eric, can you get the answer is what? The answer is what? So look, we can do this answer equals 0, and then for I in range 2n plus 1, answer plus equals fk, and return what? Return what?
Return answer.
Answer. Yeah, because here there's a special case is when n is 0, return 1. When n is 1, you should return 10, right? Because when n is 1, you should return 10. And when n is 2, look, Eric.
Yeah.
When n is 2, return will be 10 plus fk, which is f2, right? f2, which is what? f2, according to this, f2 is F2 is what? 81, right? Look, this function, Eric, this function, F1 equals 1, equals 9. Yeah, look, Eric, we're not confusing, Eric, look, you need to pay attention. We are not confusing with F and the count. Yeah, I was a bit confusing before. Fk, only calculate. F1 equals 9. F2 equals what, Eric? 81, right?
Yeah. 8 times
9 times 9. F3 is times 8. So this function,
9 times 9 times 8.
yeah, this Fk is this function, okay? And then now we need to count how many of them. So it's 10 plus F2 plus F3 plus S4. Okay, so let's the total number of numbers with unique digits. Okay, got it? Yeah? This is mathematics to calculate it, right? Alright?
Yeah.
So how are we counting? We count the 1 digit, and we added 2 digits, and we added 3 digits. Got it?
Yeah.
So the overall this count is what? F1, F0 plus F1 plus F2 plus Fn. Okay? Alright?
Yeah.
Eric, look.
Yeah.
Okay.
9 times 9 times 8.
Okay, so this is what? 81 plus 10 is 91, yeah? It's the same as 100 subtract 9, right?
Yeah.
It's the same. Okay, so now we can do this. Look at this F function, we can do it using the dynamic programming, okay?
It's only been 60 minutes.
Yeah, a dynamic programming. So look, how many dynamic programmings do we have?
Memorizations, top down, bottom up.
Top down and bottom up. Top down is the recursion with the memorization, yeah? Yeah. Yeah. Okay, so look, this F function, this F function. So look, can we write this? Fk equals Fk minus 1 times what? So look, we don't know times what, okay? Look, F3 equals F2 times 8, right? Alright?
Yeah.
Yeah, because look, 9 times 9 times 8, yeah? This is F2, yeah? Look, Eric,
Yeah.
F2 equals F1 times 9, right? Alright?
Yeah.
F4 equals F3 times what?
F4 equals F3 times F2.
No. This is F3.
Yeah.
This is F4. F4 equals F3 times what?
Times the last one.
Yeah, what's the last one?
F.
Sorry? Look, F3 equals F2 times 8. F3 equals F2 times 8. Yeah?
Yeah.
F4 equals F3 times what? Can you release?
F4 equals
1
F3. F times F2. No.
Come on, it's here. What you looking?
7.
7, okay? And then I'm going to do it. F5 equals F4 times what?
F4 times 6. No.
Okay, got it. Yeah, 8, 7, 6. So we can do this. Fk equals F1, k minus 1 times what? Times what? Can you write this? 1, 3.
What?
Alright, look. 3 plus 8.
3 plus 8. 11.
4 plus 7.
11.
5 plus 6.
11.
So that's what? 11 minus what?
3.
Fk equals Fk minus 1 times what? These two adding.
Minus 11. No.
These two plus.
1.
Sorry? What? These two. This is k. And what's this? These two plus equals 11. And this is k. What's this? Huh? Two numbers added to 11. One is k. The other one is what?
One is K and the other one is.
Is what? Come on! Two numbers added to 11. One is k. The other one is what?
F.
No.
11 minus K.
Yes, 11 minus k. Come on. What take you so long? Huh?
I
Okay.
don't know. Huh?
Okay, so look, this is the dynamic programming transition function. Alright?
Yeah.
Okay? So we can implement it using top down or bottom up, right?
Yeah.
Okay. You tell me, okay? Define f k. If k equals 0, return what?
If k equals 0, return 1.
If k equals 1, return what?
Return 1, then
Return what?
9.
9, well done.
Yeah.
Then return
The complexity is
return fk minus 1 times what? Times what? Fk minus 1 times what?
F. Wait.
Fk minus 1 times what? The one I asked you, two numbers.
11 minus k.
What's missing here?
column.
Cash, okay? Not column. I already finished. Cash. Cash. To save the values, yeah?
Yeah.
To memorize the value, okay? What you doing? Okay?
From 0.
Can we do this bottom up? Can we do this bottom up?
Yeah.
Alright.
The time complexity is 01.
Why is 01?
Because it's 01.
Why is 01?
Because it's 01.
No, it's not 01. Oh, okay. Okay.
It's everything. Is all
Okay. Okay.
Okay.
Okay. Okay. Okay. But you can make it 01. How? Because what did I just tell you, Eric? Listen. You're not playing with Ryan. Ryan said it's 01. 01. But I'm saying it's okay. But you can make it 01. Why is that? Because remember the 10 balls putting into 11 boxes.
By adding
Do you get it?
something.
So I can check. Look, if k bigger than 10, okay,
Yeah.
what should we return? Return what?
Return K.
If k bigger than 10, return how many solutions? How many?
Return.
Return what?
Return 10.
How?
K. No.
Remember the beginning I said 10 balls put it into the 11 boxes. How many solutions can you find with the unique numbers, unique
10.
digit? Can you find any?
No.
Then what's that?
0.
Yes.
0. Yes.
So do you understand why we can make it 01? Do you get it?
Yeah.
If we're not putting this, it's okay, right? It's okay. But if we're putting this, any numbers greater than 10, we are returning directly. Because we know we can't find any solutions. Eric, you need to pay attention. Do you get it?
Yeah, no.
I said at the beginning, and none of you pay attention.
Can't remember.
Can't remember. Need to understand, not remember. Got it?
Remember
It
is
took
more
too much.
important.
Okay, and look, Eric,
What?
sit down. Don't play, okay? Sit down.
I am sitting.
Look, DP, let's do it. DP array, okay? DP array, let's 10 times 11, okay? Because at most 11, okay? Yes? And then now I can do this. DP0 equals what? DP0 equals what?
dp0 equals dp
DP0, the beginning is what?
is 9.
0. 1 is 9. DP0 is what?
1 is 9.
DP0. Come on. How many within this range?
1.
1. Okay, then I can do this for I in range.
10.
Range. Let's do it k plus 1, okay? So look, if k bigger than 10, we return what? Return 0, okay? Just make sure. And then now we can do this.
1 is smaller than plus 1.
Actually here you need to start with 2, okay? Because dp0 and dp1 were already calculated. We start with 2 till k. dp, okay, you tell me, dpi equals what? And return dp what? Can you guess?
dp
dpi equals k
dpi I
K
equals
plus 1.
dpi equals what? Remember this dynamic programming transaction function. Fn equals Fn minus 1 times 11 times minus k. Remember,
Yeah.
11 minus n.
Yeah.
Okay, so dpi equals what?
I
minus 1
Times
times
11 minus n. No. K.
no
No.
F dp F
you
dp
no, you're not guessing. Minus 1. dpi equals
times what I want.
yeah, I, come on. And then return dp what?
dp
We are calculating dp what?
K.
Return dpk. Come on, this is bottom up, yeah? Because we calculate dp0, dp1, and then we're starting to calculate dp2, dp3, dp4 until dpk, right? Remember the previous one, top down. If k equals 0, return 0. If k equals 1, return 9. Otherwise, return what? F k minus 1 times 11 minus k, right? So you are calculating from the top to the bottom. This one is calculating from the bottom to the top, right? This one doesn't have a recursion, right? It
Yeah.
doesn't have a recursion, but the previous one is recursion. In order to make a recursion, a dynamic programming, we need to add what?
Cash.
We're done. The notebook memorization, okay? So with this fk, then we can do this. We can just do this. Sum, return what? Sum fn, fk for k in range n plus 1, okay? That's it. Because the final number is the number of the, if the number of 1 digit, the number of added, the number of 2 digits, the 3 digits, 4 digits, until k digit, right?
Yeah.
You add all these numbers together, right?
Yeah.
Then that's your final solution, the number of counts, okay? So what do you learn today? Just tell me, what have you learned today?
So we learned
A unique. No, wait.
unique number.
So tell me in one sentence, what have you learned today? What's the problem? And how do we approach to solve it?
So we just use, for example, if there are 10 balls and 11 boxes, you can't put them into
Yeah.
one must be empty.
Yeah.
The other must have one in.
Okay, so that's one kind of pigeonhole, okay? So for example, the other one, okay? You have 3 balls, and you have only 2 boxes. Yeah? So I can say at least one of the box contains more than 1 ball. Does it make sense?
Yeah.
You have 3 balls and you want to put it in 2 boxes. So what happened? So at least one of the box contains more than 1 ball. Got it?
Yeah.
And the previous one is you have 2 balls. Alright? You have 2 balls. You want to put it into 3 boxes. Then you can say what? At least 1 box is empty.
Yeah.
So okay? Do you get it?
Yeah.
Yeah. So why this is useful? Because look, okay, unique. Look, unique. There. How many digits in decimum?
I got long hair.
How many digits in decimum?
10.
10 digits. How many? If there are 11 digit size, if a number is 11 digits, does it have a duplicate number? Is it a unique? Is it the numbers that contains only unique digits?
11 doesn't have unique.
Sorry? It's not
Yeah,
unique,
right.
right? Because look, the best case is you can do this 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. How many? This is the number, yeah? Yes?
Yeah.
That's 10 digits. Yeah?
10 digits.
So if you want 1 more digit, what happened? You're running out of digits, right?
Yeah.
You put any digit, then it makes these not unique, right? Am I right? That's what I mean. Do you understand?
Yeah.
Do you understand now? Ryan, do you understand?
Yeah.
10 digits. This is the best case unique, right? How many in these 10 digits? Remember? 9 times 9 times 8 times 7, yeah? Times 6 times 1, right? Right? And what's next? What's next? If you times another one, times 0.
It's just 0.
It makes it 0. Got it?
So the answer is 0.
Yeah, for 11 or 12 or 13, 14. If a number has more than 10 digits, you can't find any number with more than 10 digits that is unique, right?
Yeah.
That contains unique digits because you just can't have more than 10 unique digits in a 11 digit number. Okay? Got it? This is one application of the pigeon pigeon principle. And this one is we are counting this using mathematics.
Yeah.
We also use the top down or bottom up to compute the dynamic programming. What's this programming equation mean? What's this called? Dynamic programming transition function. Because look, in order to calculate dpi, I need to calculate dpi minus 1. And this is the relation between dpi and the dpi minus 1. So you can calculate dpi based on its previous sequence. Yeah, previous item, a smaller problem, right? With this 11 minus I equation, right? How do you get the 11? Remember? F3 equals F2 times 8. F4 equals F3 times 7. F9 equals F8 times what?
F8
F9 equals F8 times what?
times 11 minus 9.
9 equals 2. Yeah, times 2. Okay, that's it. Good time.
Bye.
Have a good weekend, okay?